metacentric height. So a rectangular pontoon is 5 meter long, 3 meter wide, and 1.2 meter high. The depth of immersion of the pontoon is, it is a floating substance made of wood mostly. That is a pontoon. So you need to determine the metacentric height. The density of seawater is given to be 1025. It is slightly heavier than normal water. So this is the front view and top view of the pontoon with the dimensions. This is the front view, okay, floating in water. This is of which 0.8 meter is inside water. This is a plan view. So plan view is required to find out determine the metacentric height about the y axis. Okay, y is a horizontal axis about y axis. So dimension is given, depth of immersion is given, distance AG you can calculate, distance AB you can calculate again as 0.4 meters since 0.8 meter is inside water. Density of seawater is given. So these are the given data from the problem. So first step is to write down the given data and draw the schematic diagram if not given. That is the first step. Now metacentric height, as you can observe from the previous lectures on metacenter, there is the expression for metacentric height. Gm, that is a metacentric height, is equal to 1 by V. This V is written in a specified version. This is a Greek letter. This V stands for the volume of the object which is inside water, immersed in water. That's why V and S. A line is drawn across the V, right? A stripe. A stroke is already drawn over the V minus BG. So dimensions from the diagram BG, GM. So GM is a metacentric height, the distance between G and M. G is center of gravity, M is the metacenter. B is the point of application of buoyant force, where I is the moment of inertia of the plan of the pontoon about y axis. So that's why we have drawn that plan of the object which is floating in water, which is equal to, so BD cube by 12. BD cube by 12. So which is B and which is D? That is very important. So about y axis. So you can see 3 dimensions, 3 meters, 1.2 meters and 5 meters, right? 5 meters is the length along the y-axis, 3 meter is across the y-axis, and 1.2 meter is the height in the front view, right? So here B is taken as the dimension along the y-axis. So if you are calculating the moment of inertia about y-axis, the dimension parallel to the y-axis is B, and D is the dimension across the y-axis. BD cube. D is the dimension across the y-axis and G is the dimension along the y-axis. So 1 by 12 BD cube will give you the moment of inertia in meter to the power 4. Then volume of the body submerged in water. That's what this stroke over V represents. Okay. So the volume you can calculate as we have done in the previous problems on buoyancy. Then you can evaluate BG to be 0.2 meters. So therefore, GM is evaluated to be 0.7375 meters. Metacentric height is evaluated to be 0.7375 meters. So this is our next problem. A block of wood of specific gravity 0.7 force in water, determine the metacentric height. So here the plan is drawn on top of front view. That's all. You can draw the plan here or bottom, depending on the type of projection, first angle projection or third angle projection. It does not matter in our case. You can name it plan. That's all. Okay. So this problem is also similar to the previous one. The data given. So you need to determine H, the height of wooden block inside water, then the distance of center of buoyancy from bottom, then Bg, then substitute in the equation for Gm, that is I by V cross minus Vg. I need to be evaluated. Similar to the previous one, BDQ, B is along y, 1 is across y, then volume of wood in water, then Gm. Okay. So you will get the answer in meters. So very simple problems. Only thing, you need to calculate the I properly, and you should understand how much of the dimension is inside water, and only the volume of the object inside water, equivalent amount of volume of water alone will be displaced. So you need to equate weight of wooden piece equal to weight of water displaced. From that you can calculate this H. So such simple things you should remember, understand properly, then it is easy to get the final answer. Okay. So we will stop for today. We will continue with a new topic in the coming class.